I want to introduce the leaders of the SQL team. We have Bob, we have Assad, and you already know the title of the keynote because it's up there. Please welcome them.
Thank you so much, Andrew. Thank you. On behalf of our team at Microsoft, we're so honored to be back here at Visual Studio Live, especially hosting you here on the Microsoft campus. Question about my mic? It is on. So, okay, we're good. So, again, thank you so much for being here. Thanks for the honor of getting a chance to tell a story. I've got a story to tell you today. A story how we think Azure SQL Database can solve challenges for developers from the startup to the enterprise and everywhere in between. A couple of housekeeping things before we get going. Number one, we know you're going to have some questions. We love to answer questions. So let's do this. Let's reserve those questions for after this session or at the Table Talks lunch. We're going to be over there and can meet you in person to answer anything you have to ask about what you're going to hear about today. Also, I know many of you are like, I'd love to have the content right now in my hand. You can get it. You see this URL right here, ak.ms, bobword.ms. The talks that I've done at this conference, this keynote deck exists. They're already right there today. So you can pull down that content anytime you'd like to see, including information about the demos we're going to show you. So to kick things off, I think it's most appropriate to have the leader of Azure SQL, SQL Edge to Cloud, our Vice President, Assad Khan, kind of get us started today. Assad?
Thank you, Bob. Thank you, Andrew. It's really, really exciting to be a part of this community, part of the Visual Studio Live. I love the conversations which I'm having, both inside the room and outside. It's so exciting to see all of you using the latest features that we are releasing, whether it's on the Visual Studio tools, whether it's on AKS, web app, on Power Platform, data platform, and obviously we all love the Copilot experience that is made available by Microsoft. So thank you for all of that. My background obviously is in data platforms and databases. So I love the conversations on the data-centric applications. And obviously, it's no surprise that these days data is what is powering the value for many of the companies. It is not surprising, for example, if you look at companies like Airbnb and their market cap, it is double the market cap of the companies they compete with, whether it is Marriott or whether it is Hilton Hotels. Those chains might own thousands of real estate, and Airbnb does not own anything other than how they make use of their data and how they connect with people. So that is the power of data. And obviously, all of you as developers make that possible. You take the data and you light up exciting experiences for your enterprises, for your own businesses. And that is what keeps us exciting in terms of what we build on the data platform. We as the database platform owners, we are responsible to make sure your data is secure. It is reliably available. You get the scale you're looking for. You get the elasticity. You get the latency. All of that is, again, something which we are really, really excited and we continue to innovate in that area. Being the GM for the SQL, I get to talk to a lot of enterprises, both the startups as well as large enterprises, whether from all verticals, whether it is banking, whether it is retail, and you name it. The requirements might look on the surface a little different. Obviously, if you are a startup, the cost that you are putting in initially, it matters to you. The time to market is super important. The familiarity of what languages and what tools you are using is super important because obviously there is not much time to go and learn new stuff. You have to get to the business you want to push in front of your customers. Similarly, if you look at the enterprises, like obviously cost is super important to them as well. And especially these days, in these economic conditions, it's like, what is my ROI? That is the first question that I get when I enter in any conversation with the senior executives. Like, okay, if you're talking about modernization, if you're talking about a new app that they want to go and launch, what will it take to do that? And obviously, what is the return for my business is super, super important for them. Similarly, the DevOps and the project lifecycle. Imagine you are the DHL, you are the bank, you are the retail, and you have something in production. Obviously, it's not going to be static. You want to keep innovating. You want to keep changing that thing. It is super risky to touch that production system unless we, as Microsoft, don't invest in end-to-end solution of what is the CI/CD pipelines, what is the DevOps for your projects. Similarly, the flexibility, the standards, the reliability, the security. But if you take a step back, many of these things are common. Whether you are talking about startups or whether you are talking about the largest enterprises that we support. And over time, we have definitely also seen a lot of shift in this industry. I would definitely highlight the one which is the last two, which is what has changed is that more and more developers are directly interacting with the databases. Before that, there used to be more personas which were out there. Now we see more full stack developers. They are the same ones who are writing the applications, whether in Java, JavaScript, or Node, and you name it. And they are also the ones responsible for making the databases perform and be available. And that is something which we take as a very serious challenge in terms of how do we convert a feature into a capability. When I talk about feature, SQL might have a great disaster recovery feature, but that is not important. What is important for you as a developer is the capability that my database should always be available, and just make it available. Why do I have to do something around that? And that is something we take it as a very, very strong challenge, because we want to make our databases accessible to everyone, whether they know the database or they don't know. And that's why today, although this is titled as a SQL conversation, a lot of our discussion will be around what database offers to you as developers. Whether it is about like how do you get started without spending any money, whether it is about the local development that we offer, whether it is the choice of the platform, whether you are working on Windows or Linux or Mac, it should be equally accessible for you. Whether it is about the built-in security and scalability and elasticity. Obviously, in the cloud world, everybody is looking for the elasticity. How can I store my data without the worry that I will ever fill that thing? And that's where we have innovated in the core engine of the SQL. And we today have a lot of databases which are more than 100 terabytes. We have a customer who have an IoT scenario who pump all their data streamed into one table. They have 1.7 trillion rows in one table of SQL Server. Similarly, like obviously we run on Azure. We are the tier 0 service on Azure, which means we are available everywhere. And what is obviously differentiates SQL from many other data platforms is that we are also equally available on-prem in hybrid environments and even in other clouds. And that makes it super interesting. We have a lot of customers who still have some footprint on-prem, and they say, we want to do the DR between on-prem and the cloud. And all of that is possible because for SQL, we don't have to think, how do we bring some capability outside of Azure? It is already there. And obviously we have, this is not a statement about the future where we want to go. Today, Azure SQL is by far the largest PaaS service that we run in Azure. We have over 10 million databases in production. And we update all those databases. These are all versionless databases that we update with a promise that no application will break. Today, if you look at any other database out there, they all have versions. You have to worry about like, how do I get from version 16 to version 17? Whether it is an easy operation or hard, but you have to think about that thing. In Azure, when we run SQL, it is all versionless all the time. And we can upgrade with the promise that nothing will ever break. Similarly, if you look at the number of the queries, we run over 70 trillion queries every month. And guess what? Like, if you look at all the capabilities that we have built in SQL with the intelligent query processing, all of that power is automatically delivered to all of you. Again, as I mentioned, with Hyperscale, you can have any database, and we have a lot of customers who are now running 100 terabyte plus database, single database of SQL. And again, if you look at our customer base, obviously this is SQL, so we power pretty much every enterprise in the world in some form. But these are some interesting cases because it shows the variety in terms of and why SQL attracts them. If you look at BKW, which is more of an IoT scenario, they love the fact that they don't have to use multiple databases, whether they want to run some graph queries versus some relational queries, and the scale that it provides. Similarly, if you look at Perlibus, like any gaming company, it is so exciting that the the success of a game is pretty much defined in the first 24 to 48 hours when it is launched online. The challenge it brings for these companies is that they have to have an architecture which is cheap, but can also scale if this becomes a huge success as a gaming. So they have launched multiple games with us, all running on Hyperscale without the worry of the cost, whether it is a small database or it becomes the next big game for them. Same with ClearNet, a financial company, obviously SQL, the security it provides, the cost management it provides. Microsoft Dynamics is a super interesting thing. I don't know how many people know, but all of the Microsoft Dynamics is powered by SQL. They run millions and millions of databases without any DBA. It just works for them, and that is why they are able to so fast innovate. Whether we look at the Power Platform, whether we look at their CRM solution, all of that, it is powered by SQL. And they had an amazing transformation all the way from running on-prem to the modernization into the cloud, moving from provision into serverless, into pools, into hyperscale. A great example, and something which we are able to talk in detail because it is obviously Microsoft own use case. So again, as I said, although this is SQL and this is we consider it as the best relational database, but often the conversation as we are talking to folks like you who are the developers, it is less about the relational database. It is what do we offer beyond? And that is where we want to spend more time today. And let me invite back Bob, who's the architect, to talk more about what is the beyond RDBMS.
Thanks, Hassan. Appreciate it. Thanks for setting the landscape of what we're going to talk about the rest of the session. So I was thinking about this talk that we're going to do. I was at dinner with my wife, and she's like, "What are you doing?" I'm like, "Well, I'm sketching on a napkin." I do that a lot. She's like, "Look, can you just pay attention to me? Like, why are you sketching a napkin?" I'm like, just give me a few minutes. I have this idea. I'm doing this keynote thing in Redmond campus, and I have this idea of this phrase called beyond RDBMS. And she goes, "I don't even know what you're talking about." It's okay. Don't worry about it, hon. I'm going to keep sketching. So what I did is I said, I'm going to sketch it. By the way, I had dinner with the rest of the time. I started sketching later. But the thought was in my head, what is inside this database that is beyond what I've been spending 30 years of my career on? Because I've spent my career 30 years talking about relational engine stuff. Look at this list. Consider the fact that now built into this engine is support for Json, spatial queries, a graph database with no add-ons into the database itself, column store indexes, add indexes for analytics with no code changes. Or the fact that you get a blockchain in SQL. A blockchain in SQL? Yeah, just declaring tables to be ledger tables. Or even memory optimized for low latency transactions. And then it starts to get really crazy, which we're going to show you today. How about integrating in your database application a conversation with REST API services? Or how about go start writing queries with GraphQL? Does this sound crazy to you? This is not your normal database engine. It's a data platform that's actually amazing. But even yesterday, I did a talk on containers. I had this audience going wait, SQL runs as a container? How does that even work? And we're going to talk about today that some of the abilities we have to run on containers give you that local development experience that feels like you're using SQL in the cloud. But we want to make sure that we take care of developers. We want integrated, rich capabilities for DevOps with things like GitHub. So let's do this. Let's spend the rest of the time talking about these three areas. How do we provide capabilities for you as a developer for the local development experience, again, across all the different OS platforms that you want to work on? How do we give a rich experience for app development? We want to make sure there's something tight there with these new services I just talked about. And then finally, we still think we have a great data platform that's needed to power startups to the enterprise. So for local development, there's some innovation we've done recently you might find interesting. Number one, we want you to use that concept that's been around for a while called database projects, but in a new form called SDK-style projects. Much more efficient if you go out there and create database objects, stored procedures, things you use with a database in a very development seamless fashion, and do with things like Visual Studio Code in a very easy way. But we also need to provide you, like we talked about, this free development experience that feels like the cloud. So we announced something called the Azure SQL Database Emulator. This is using the power of containers, whether it be on Mac, Windows, or Linux, to get that free local database development experience along with these projects. But you need GitHub. You look at the diagram on here, this concept called inner and outer loops, we call it. The inner loop being local development, the outer being integrated with your GitHub repo, or even eventually the Azure SQL Database. So we want to go and take advantage of the power of things like GitHub Actions and integrate it deeply with these SDK-style projects. And then we want to give you new innovations for utilities that help you develop faster for something called Go SQL Command. So speaking of that in mind, we came up with this idea that GitHub Actions can be very powerful for event-driven development for DevOps. You may have seen things like GitHub workflows, GitHub Actions, runners, and even using containers. So what we've done is taken the process of building database projects, of publishing schemas of database projects, right? And integrating that into GitHub. We call it the GitHub SQL Action. So now you can go out there in your GitHub workflows and have a declarative way of defining how to go build your SQL code, how to go publish it to a local container for testing, or even publish it eventually in production to an Azure SQL database. But there's more. We want to integrate this new Go SQL Command utility in with scripting languages as part of the workflow. Yesterday, I showed in my container session how to do a smoke test, how to go integrate the ability to make a change to a stored procedure and then run a quick smoke test automatically with GitHub runners and actions to ensure that proper indexing is used with your queries. So you have this new rich DevOps experience that you've had with GitHub, and now SQL is a big part of that game. In addition, some of you have used the SQL Command utility. I've used it for many, many years, and it's a great utility. It's great for running just interactive queries at the command line, but also great for scripting capabilities. So we took a look at this. We said, hey, we want a new generation, what we call Go SQL Command. Now, the utility is still SQL Command, but we call it Go SQL Command because you're using the Go language, and it's all open source, using the Go SQL driver to drive the scripting experience. So why is it different? Well, here's the biggest one right here. Number one, look at all the different platforms it runs on now as a developer that you may need. And second of all, this is powerful. My colleague David is just smiling up front right now because he uses this now religiously. And that is using this Go SQL command, you can spin up a SQL Server instance with a database, very easily use a container, no setup required to set up SQL Server. Just use the utility to say, I'd like a database, spin it up, run a container, and start developing against it. But we want new experiences. We want things like configuration context. I love the vertical formatting that you get from it for large type of tables that have large columns, and even things like console coloring if you're into that kind of type thing. So those are two areas in local development we're doing. Now, everybody in this room is certainly got on their mind AI. And Microsoft has come up, obviously you've seen this concept of Copilot type technology with many different things we're doing in Teams, and Office, and even across Azure. The GitHub team has built a Copilot for GitHub. We have now integrated that into Azure Data Studio. Maybe you've not heard of that tool before. It's a cross-platform tool that you can use to develop and write SQL queries as a developer. And so what we've done is now integrated GitHub Copilot into Azure Data Studio to give you great assistance in building tables, building queries, smart type things to help you not make mistakes, and get you up fast in doing database development. So think about what I just talked about. GitHub integration, database projects, a new SQL command to make it easier, an entire DevOps experience. But there's no better way to show you actually how this works than to show demonstrations of it. So let me invite Mwazma Zaid and Davide Mari, two of the leaders of our developer experience in Azure SQL Database, to show these things in action.
Thank you, Bob.
Thank you.
So, Mwazma, I prepared a couple of demos.
That's
You
good.
want to go there?
Yeah.
Yeah, so it's probably easier. And so let me start to show something just Bob mentioned that I really, really like. So one of the things I normally get as feedback when I say to developers, go and use SQL Server is that, how much does it take to download it and install it? It's so complex, complicated. I will spend the entire day just to set up my machine. Well, maybe it's not true anymore because with the new SQL command, I can do everything in just 1 minute. Let me show you. And I'm starting from a machine that is completely freshly installed, completely blank. So I start by basically using winget install to install the SQL command. And the SQL command is a tiny application, 6 megabytes, that can be downloaded in a second. And now I have SQL command installed. Version 1.0 is the latest one, so that's exactly what you will get. And now I have SQL command, not yet SQL Server. How much does it take to install SQL Server? Well, the only thing I have to do is SQL create. Then I specify MS SQL because I want to use MS SQL. I accept the user agreement, I specify the name of this installation, I specify the port, because I may have more than one installation on the same machine, and I even specify that I want to create a database completely blank, so I can just start with the right database and not the master one. Right. And yeah, that's pretty fast, right? Then everything is downloaded. I already have the container cache on my machine, so it's super fast. After the download is finished, SA is disabled, so it's secure, and a new user is created, and then also a new database is created. Now that's it. SQL Server is installed and running. The only thing I have to do, as you saw, is SQL Command open ADS. It will open Azure Data Studio and automatically connect me to the database. So I don't even have to remember, connection string and other stuff that's quite boring sometimes. And I'm connected and it's working. That's it. 1 minute. This is exactly what you can do today. In 1 minute, you can have your database ready to work, right? So this is really, really nice.
That is super exciting. What is this Copilot stuff that Bob keeps talking about?
Yeah. So let me show also about that. So let me connect to another machine. And here I have a JSON file that I know my developer, or myself, if I'm a full stack developer, I will be using because I will get it from some REST API that I will be calling. And I need to store some of this JSON data into my table, right? Perfect. So let's see how can I do with the aid of Copilot to be more efficient, more productive. So first of all, I'm just pasting the sample of this JSON data into the ADS that I have opened as a comment, and then I want to create a table called vehicle position because this data contains information about real-time data of buses here in Seattle, right? So I want to store information about where buses are in real time. And as you notice, Copilot already helped me and suggested me all the columns that I should create to basically save all the data into my table. Of course, I don't want to save all the data. And also, as you probably notice, Copilot, since I didn't do any prompt engineering, so it tried to do its best, but float for latitude maybe is not the best option. So I am, helping Copilot that helped me to be productive, to create the perfect table that I have in mind. So I am removing some of the data that I don't need in this table. I'm changing the data type to be exactly what I need. And honestly, if I probably have done a little bit more prompt engineering, specifying exactly the constraint in the comment, for example, it would have created an even better table, but just to show you that basically you can start very easily. Now let me create a primary key. It's going to be a non-cluster index. Now I want to take some of the data and still keep it as JSON. So I'm creating a new column that will only contain some JSON data based on some variable data that I may have or may not have depending on the bus stop and depending on the IoT device on that bus stop. So now let me just finish the script here and execute it, and that's it, we have the table. Nice. So Copilot helped me a bit. Now I want to use the real data that is not in a comment, right? I have my JSON data in a variable. Let's assume that I received this as in a variable. And I want to make sure that I can insert this data into my table, again, with the help of Copilot. So I collapsed everything so it's easier to follow, but cool. Copilot figured out that I need to do open JSON to open the JSON, and it figured out also what are the correct instructions to extract only the data I want from JSON based on the table I created before. That's pretty amazing. Now, what I need to do right now is only basically take the data that I don't want to be as JSON in general, because I want to extract some of the information from the JSON data. So I don't want to keep all this JSON here, right? So what I want to do is insert this data, transform a little bit of the remaining JSON data, and that's basically everything I need to do in order to be able to create a table and maybe also put this in a storage procedure to ingest the data that will be sent from a REST endpoint, for example. So again, Copilot is helping me here to autocomplete the column. Everything that you see that is autocomplete is done by Copilot. And here, I'm going to use a new function, JSON object, that Copilot never saw before because we just released it. And of course, I need to manually specify how to build a complete JSON object from scratch using the data I had from the previous JSON. And once Copilot learned to do it, it can automatically help to add the properties I want to the JSON because it learned from what I did. So in, 5 minutes, I could start from a completely empty database, the one that I created with SQL Command, create a table, understand how to process JSON, create the insert command, do some transformation, all with the Azure Copilot, which helped me to be more efficient, right? So it's really, really supporting me to be a better developer, I would say.
That is really exciting. So we did like local Go-based SQL command.
Yep.
We were able to create the database, use it offline completely for local
Oh,
command.
yes.
And then we connected the ADS. You can start using data, and you're done.
In 5 minutes. That's pretty cool. Right?
Back to you, Bob.
Yeah,
Back to you,
gosh.
Bob.
All right, that's pretty cool. That's nice. That's very nice. One just comment about the Copilot when Davide was showing this. I was like, Davide, this is really cool. He's like, Bob, you don't understand. We're just getting started. So expect from us a lot more innovation in this space to make you more successful. That's a local development experience. I promised you some app development experience. Like, how do we make that app development experience better? And it's interesting that Davide chose to use JSON in his demo. Many of you don't know, he used some of the functionality that we started building way back in SQL 16 and in Azure SQL Database to process JSON. Look, we know the reality that JSON is the most common format of data in the world. We want to make sure that the SQL language has the robustness to process that. And so you saw some of the functionality he used, the fact that you can go open a JSON document, put it inside a relational database, you can actually bring stream data out as a JSON document, and even be able to go in and manipulate it. In SQL 2022, which we just launched last November, and in Azure SQL Database, we extended that. We actually extended the functionality to process JSON data, including the ability to produce things like JSON objects and JSON arrays. However, the one thing you've noticed in the demonstrations here is that the data types were strings. And we realized that you've been asking forever for this. So we announced this past May at Microsoft Build a new JSON native data type that's coming to Azure SQL Database. It's in private preview today. If you go to that link right there, it's the ability for you to get a little bit more information about what we're doing in this space, but also for you to sign up for the private preview as a developer to go experience what that's like. I'm very excited to see this happen. It's been a long request from our developers. We're now putting this inside Azure SQL Database, and eventually that'll show up in all the different SQL properties that we have. Included in there is also some new functionality to do aggregation. So imagine doing queries against a JSON data type and bringing back a complete JSON document towards your application. So having that rich new data type is a huge part of the app development experience. But it goes further. So I remember, funny story here, I love telling stories. I'm on an airplane, traveling to an event, and I'm on Teams, because I'm on the internet, and I ping Davide. I'm like, Davide, I'm trying to learn more about Data API Builder. I've heard about this thing you're working on. Like, I don't really get this. Like, can you visually describe to me what this is? Davide, on the plane, drew this diagram for me, and we interacted together about what this means. And then he started telling me more about the richness behind this. And that is this. You write code all the time today to interact with databases. What do you got to do? You got to do a connection string, you got to connect to the database, set some properties, you set up queries, parameters for stored procedures. There's a lot of plumbing code that goes into writing code to connect, authenticate, and query a database. So what we've done is taking a concept called Data API Builder to generate code for you, .NET code, and allow you to use interfaces like GraphQL to do the actual querying or even manipulation of data in the database. Now, Data API Builder can be used in any context you need, but look at this powerful visualization story about how well it is integrated with static web apps. So imagine now building a static web app application using JSON to actually go out there and GraphQL or REST APIs to connect, query, manipulate data, and actually get data. That is a very powerful story, and it's going to save you lots of code. What does saving lots of code mean as developers, you know? It saves bugs. It's going to cut down time for development and make your code more high quality. And then we're like, okay, well, what else is a picture? Davide showed me this picture. I'm like, what about this Azure Function story? What does that have to do? What does that help part of this? He says, well, Azure Functions are hugely popular now for serverless programming. And so we wanted to have a play in that space as well. So in addition, what we do is we have a tight integration with Azure Functions for data. Like, you know, when you're running functions, you need to bind input and output really easily. Or maybe you need to like trigger based on data changes. So now Azure SQL Database has a deep integration in with Azure Functions for data binding and for even triggering of events that occur for data changes in your database. That's a powerful story. You have JSON data types, and you have a way to be a developer, be way more efficient. Oh, when I was talking to a customer about this concept right here, they said to me, now wait a minute, let me make sure I get this story straight. You mean now, and I use stored procedures for everything. I can simply just call all my stored procedures from like REST APIs or GraphQL and say, yep, you have cut down way much code in your database just to go execute what you consider server-side programming. So that's a pretty cool story, but there's more. So as I was talking more to the team about what are we doing that's beyond RDBMS, I looked at this REST endpoint interface and I'm like, tell me the story here. Like, what are we doing? What are we trying to achieve? We're trying to achieve this. Instead of you putting a lot of your code in your application to go get data and then maybe integrate using JSON with REST endpoints, why not do it in the engine? Like, why not use stored procedures to actually go interface with REST endpoints to retrieve data and get data through JSON? So consider these scenarios. Maybe you've heard of something called OpenAI, slightly out there in the news. You can now interface using SQL procedures with your data in a seamless way with OpenAI. Or quite frankly, any REST API you can think of that's in Azure today or one that you build. All in a very integrated way with JSON. But there's more. Just recently, we announced the ability to integrate this technology with Azure Storage blobs natively. So think about even reading and writing files from Azure Storage. Could be text, could be XML, whatever you need outside of even JSON capabilities. So you can see this is why beyond RDBMS, we're extending your ability to use the database in a new and intuitive way to go after new scenarios and new applications that before required a lot of code from you to get data, retrieve it, interact with these services. So what better way again to show you this stuff in action? Let me bring Davide and Mwazwa back up again. Guys, what do you have to show me this time? Something? Okay.
Yeah.
Something pretty cool.
Something pretty cool. Got it. Okay.
Yeah, I prepared a couple of, actually 3 demos. So let's start with the first one. The first one is on Data API Builder.
Nice.
This is really minor, and hopefully you will like it too. So first of all, I want to highlight that everything here is happening offline on my machine, okay? And on the left, you have my console, where I will be typing all the commands to create a Data API Builder, set it up and run it. And on the right side, you will see what's happening on the configuration file, because all what I'll be doing is based on the fact that there is a configuration file behind the scene that is used by Data API Builder to understand what tables, views, and storage procedure you want to publish as a REST or GraphQL endpoint. And of course, what security you want to put on it. Because the moment you publish something on the internet as a REST endpoint, you want to make sure that it's secure, right? And we take care of it. So let's get started. So first of all, I want to install Data API Builder. It's very easy. It's a .NET application. So I just need to do .NET tool install Microsoft Data API Builder. Of course, it's already installed in my case. And now I can just check the version. The latest version is 7.6. This is not updated, but it's still the same. And now let me show my database. I have my database of real-time data of buses around Seattle. And let's say I want to publish something about the stops. So I want to publish a REST endpoint that will allow any developer to query the data in the stops table. Then I have a view, and I want to publish also the view to make sure that any developer can use GraphQL, for example, to interact with this data, maybe to show on a map where each bus is using latitude and longitude. Or let's say that I want to leverage a little bit more the SQL engine, because you know that we have the geospatial engine. And I want to create a storage procedure that, given latitude and longitude position, will tell me what are the closest bus to me that goes in the direction I need, right? So I want to use the ST distance in order to be able to calculate, find quickly what are the buses that are close to my position, taking into account the fact that the Earth is a sphere. And make sure that I only select the buses that are within a certain radius, pressing kilometers here. And I want to publish this storage procedure, again, to be a REST or GraphQL endpoint. Normally that would take a few time, because I have to code everything. I have to code pagination, I have to code filtering, I have to code everything that you would expect from a REST endpoint. Instead here, I just have to initialize the API Builder, specify that I want to use a database that is SQL-based, SQL Server, specify the connection string that can be obviously set in an environment variable for security reason, of course. And then here I'm setting the host mode to development, so you will see everything that happens behind the scenes. So every query will be logged, so you will see how we translate GraphQL to SQL, for example. Now that this is done, you see that the Data API Builder created a configuration file with the section that is completely empty. Entities is the interesting part. It's where the tables, view or stored procedure needs to be defined in order to be published. Because by default, it's not that we publish all your database right away, right? Again, it will be a security issue. So what I have to do is just do add stops. So inside the table, define the permission. For now, here I'm saying anyone can do anything, just for simplicity. And then I want this table to be reached at the stops kind of endpoint. So everything can be configured to look like what it would look like if I had coded this by myself. So we don't impose you any naming convention, anything. You can choose and configure everything as you want. Now I'm also adding a view. In this case, I'm saying that I only want people to be able to read. And again, I don't want the view to be called the view vehicle position data when it exposes a REST endpoint. I just want to have a shorter name called position, and that's it. So you will see that, again, the configuration file is updated. And the last thing I want to do is add the storage procedure, right? But as you can see, everything is based on the configuration file. So the CLI, the tool that I'm using to build the configuration file, is just an end. If you want to build the configuration file by your own, yeah, you can do that. It's just JSON. The schema is published, so it's super easy. Here I'm adding the storage procedure. I'm specifying what parameters will be able to be exposed and what are the default values if someone doesn't specify in the REST call, and again, the permission. Easy, done. My storage procedure is also configured to be exposed. Now, basically, the only thing I have to do is run Data API Builder, which is a stateless application, so it's very easy to make it scale out and run it in a container or in a service like static ABAPs, and just run it. Here, I have the configuration done, as you can see, with all the detail for the storage procedure and everything, and even the actions. Action is where we can define who can do what, like can you issue a post request, a get request, and so on. And now I just did dub start, and that's it. Healthy means dub is running correctly, so I can go to GraphQL, and locally, in development mode, I have a full GraphQL interface that I can use to query my data. So let's query the position, for example. Specify that I want to have only the position for a certain vehicle. That's it. That's GraphQL. And this is coming from my database. Very easy. Imagine if you had to code everything by yourself, implementing all the best practice, code retry, connection retry logic, all the correct error handling. And here is another example using instead of storage procedure. So here I can also call a storage procedure from GraphQL. And thanks to GraphQL, I can even decide what values are returned and what not. So this allows me as a developer to be super efficient because I don't have to basically build the entire middle tier. I can just use it. And if I don't trust the data builder right away, you can see what query we are generating on your behalf. Always. So you are always in control. You can always see what we are doing. Now, the latest version of Data Builder, we added something that has been requested on GitHub because everything is open source here. The entire project is open source. We added support for OpenAPI. So you also have a Swagger endpoint, and all your REST API published by Data Builder are available as a Swagger documentation on OpenAPI, and you can even try right away. So you have basically all the REST operation that you want with the correct security, and we will have a session on that where we go a little bit more deeper into the security available. And here I can make a REST call before I show you how to make a GraphQL call. Now here I'm using a REST call. I'm issuing a post command to call my storage procedure. And again, here's my storage procedure called and executed, and I have the data back as JSON. So imagine how efficient and how productive you can be if you don't have to build every time you want to publish a table, a review, or a storage procedure by yourself. You can just fire it up, Data Builder, configure it, and in 1 minute you're done. Your table is available as a REST and GraphQL endpoint. This is pretty cool.
That is amazing. So what you just did, let me just recap that, right? So you had your database objects, you actually use your tables, stored procedures views, all exposed as GraphQL and REST within the last 5 minutes.
Yeah, basically, yes.
That's amazing. Yes. And this is all open source, so these folks can contribute towards this.
Oh yeah, absolutely. So you can contribute if you want. You can go open GitHub issues, make any proposal to improve the product. For example, the OpenAPI support was from a customer, and we are trying to release everything every couple of months. So we really try to be agile here, and this is the result. So I think
what's the link they can go to?
aka.ms/DAD, that's the link where you can go to basically directly go to the GitHub page of Data API Builder.
Awesome. So you said you had 3 demos.
Oh yeah, that's right.
We have to go 2 more. We have
Cool.
some time.
So this is basically if you see the architecture that Bob showed before, this is to publish data from Azure SQL to the outer world. But what if you already have an endpoint that you want to call? For example, one of the things that Bob mentioned we just improved is the ability to call a REST API, any REST API, but specifically the storage REST API.
Yeah.
So let's say you want to have a file, or you have a file in your Azure account, and you want to read it from Azure SQL. How easy is today? Not easy, right? Because you have to use or Azure Data Factory, or build some function to basically access the storage account, open the file, do everything. I mean, it's not that you don't have to do it in the future, but maybe if you don't have strict requirements, you can just go and use the storage procedure I will be showing you. So let me start from my Storage Explorer. I have a file here. So I already opened my blob account. I'm in the playground folder, and I have a file called lorem ipsum, which, of course, as you can imagine, contains just some random data. And I want to read from that blob. That's what I have to do. I just connect to the URL of the blob, use the storage procedure sp invoke external REST endpoint, and that's it. Now, the REST API of storage account return a XML payload, and the content of the file is inside the result element. And so, just using the regular XML support that we also have in SQL Server Azure SQL, I can extract the content. And the content can be anything. Can be XML, can be text, can be JSON. Now, what is instead if I need to write to a blob or a file or a queue? Because you remember that a storage account supports several type of objects. Well, I just have to send a put request correctly to the endpoint, specify the content. In this case, the content uses some JSON data, welcome. And here the file has been created. So I can go to my storage, refresh, and you will see that now there is a VSLI folder with the file name that I just created. And that's it. Let me open it right now, and you will see that the content is the content that I created using the JSON object. Here we go. So I created a file, more specifically a blob in this case, in my storage account right from Azure SQL, 1 line of code. Oh, that can open quite an interesting amount of scenarios, especially if you are doing ATL or other transformation.
So just to recap this as well, right? So you're using the SP invoke REST endpoint for procedure to call any REST endpoint, and you just gave us a demo of using blob to read and write.
Exactly.
What about if you have to connect to OpenAI? I know
good
most
point.
of folks are thinking about that.
Yes. So, you know, OpenAI, I guess it's kind of famous right now, but one thing you may want to do is use OpenAI to convert any text. Let's say I have the text called, the text I wrote, I like science fiction, so I really like Isaac Asimov, the Foundation series. So let's say that I have a database where I have some articles, and let's pretend that I imported all the 25,000, not all, but 25,000 articles from Wikipedia in my database. Using OpenAPI, I have converted those articles in numbers, in vectors, specifically in something called embeddings. And now I want to use that vectors, that embeddings, to quickly search to find what are the articles that are closest to the Foundation series by Isaac Asimov Center. So basically do what is called similarity search. And a very common way to do similarity search is calculating something called the cosine distance. Now, you probably have heard about specialized vector database, but be proud yourself to be able to have a lot of stuff in the engine, so you don't have to go around and search for the specific database where to do some stuff, because the more database you have, the more data, your data is scattered around. So good luck keeping everything, logically consistent. So if I could do similarity search right in Azure SQL, that would be great. Let me show you how. I can just call OpenAPI to transform my text into a vector, right? So that I can then calculate the cosine distance. And this is exactly what I'm doing. I'm calling OpenAPI using SP invoke external REST endpoint. I'm passing the text, and I will get back a series of numbers, a vector. You will see right now here that this is the answer, and these are all the numbers that represents the content I have sent to an OpenAPI. Now I can store this data, this vector, in a table, for example, and this is exactly what I'm doing using OpenJSON, because at the end of the day, the rest send JSON, but it looks like a table to me. Then I can create, for example, a column store on this number to make it super fast the search on my 25,000 article using consistent instance. And in a few seconds, I have the list of all the articles that are available in my database that are related or similar to the content I have specified. You can do this today using Spinbook external REST endpoint and the column store and the JSON. And this is exactly what I like about Azure SQL. Different pieces, but working very well together to build something that otherwise would require many lines of code, not just one.
Yeah, and this is what Bob is mentioning beyond RDBMS, right?
That's right. It's way beyond relational now. It's open to everything.
Awesome.
That's pretty cool.
Back to you, Bob.
What do you think, Bob?
Awesome. Yes, that is definitely beyond RDBMS. Thank you.
Yeah, it is.
Yeah, I love the way you kind of piece some of this together, because one thing you did, like you threw column store in there, like just so that's a core engine feature, but just adds on top of the type of functionality we're integrating the engine. So local development, app development. Let's kind of finish off today and talk about the firm foundation of the platform. So being this my 30th year at Microsoft, I'm kind of the de facto historian of this team. People come to me all the time going, Bob, do you remember back in 19, whatever, what we did back then? So when I was researching about this talk, I thought I'd throw these two numbers up for you. Did you know that SQL Server as a Microsoft product has been around for 30 plus years? But what you may not have known is Azure SQL Database was the first platform as a service database in the industry, now 13 years old. We first launched SQL Azure, we called it back then, 13 years ago. So we kind of know what we're doing. We have an engine that's proven, we also have a platform that's proven. And when I think about a firm foundation, I first think about security. I want to make sure that whatever I'm using has built-in encryption, that's well protected for my data, that has features like SQL Ledger, I mentioned that earlier. Yeah, now today you can just go declare a database or set of tables and get tamper evidence proof, like a blockchain, inside the database itself. But I need to be performant. And you may not know, but you can be assured that for 30 plus years, we get how to do that. Like the engine scales itself very well. So even if you run SQL Server on your laptop, in big iron servers or in the cloud, the engine itself knows how to scale to make sure that you're taking advantage of all the resources you get. The heart of query processing in the engine is critical to your application. So one of the things we invested in the last few years is something called intelligent query processing. We want you as a developer to spend less time being experts on tuning queries and let the query processor adapt to the workloads you have. You can just go look up this IQP subject and see all the scenarios that we've learned throughout the years of mistakes or different types of queries developers or customers have sent to the engine, and how the engine can almost in a way self-heal and run faster as it sees your queries come into the system. But also it needs to be available. Now, it's a lot of time and effort sometimes for administrators to help build a highly available SQL server for you. In the cloud, it's all built in. HADR is completely part of the database that you're paying a subscription for. And we're using the power of engine technologies, though, that we've built throughout the years, like availability groups. But this one's very interesting, and I see a lot of developers sometimes struggle and tell me, my SQL server is struggling because my operational workload and my read workload are running in the same instance. Well, built into the cloud service is the ability to do read scale. So you can take your read type workloads and run them on read replicas somewhere else than the primary database that's serving the operational workload for your business. So with that kind of in mind, I think there are three things about specifically running SQL in the cloud you should know about. You may have heard of Hyperscale. That's how we achieve the numbers that Asaf was talking about earlier. The ability to run 100 terabyte type databases in the cloud, the Hyperscale type technology. But we also know that you may not know when you provision a database how many cores or resources you need. So we built this concept called serverless. Serverless being the ability for us just to scale as you need based on your workload. And I'm proud to announce that we have a preview now to combine those technologies, Hyperscale and serverless together. In addition, we'll show you in a second here, we've been able to combine the technologies of Hyperscale and something called Elastic Pool together. So you look at that visualization, and you think about the title of our talk, Startups to Enterprise. We think we have a database where your code doesn't change, we just scale as your business grows. We really strongly believe in trying to turn applications passwordless. So in Azure, we have a concept called managed identity, if you haven't seen before, well integrated with our database service that allows you to achieve that. And then finally, you have to make sure that if you're going to trust to run SQL in the cloud, we just have your back. So we have this concept called always on. And we have an SLA, a service level agreement behind it to make sure that your database is always going to be around whenever you need it. But Assad talked about we're geographical, we're all over the world, so we better be redundant. And we run all these different data centers and regions around the world. So we have built in things like zone redundancy. We can keep your data redundant within regions of data centers around a part of the world, or even geo-redundant. You'll be able to take your database and easily replicate it across regions and access it for things like read scale if you need it. So with that in mind, I want to make sure you know that we just announced a public review for something called Hyperscale Elastic Pools. Elastic Pools being a technology that we've had around for a few years with Azure SQL Database. And the diagram right here kind of says it all. Developers came to us and said, I'm building cloud applications. I have thousands of databases to manage, but the workload that hits them is not predictable. So I'm in this kind of weird game where I'm paying for this really high cost of not knowing what the workload looks like for each database. So can you help me? And we built this concept called Elastic Pools, where you can share the resource cost across a bunch of databases and kind of pay things more in an average scale. Well, that's just great, but I love that hyperscale feature too you've got out there for 100 terabyte databases, and we brought them together now. So now you can go out and deploy a hyperscale database along with Elastic Pools and achieve that great cost savings across these different assets. Imagine a world, for all of you in the room right now, where Azure Database just becomes all of this by default. Like at some point in time, it's just hyperscale, it's just serverless, it's just elastic, it all just works in a very seamless way. This is why Assad was talking about the future of what we're doing at the beginning to make sure we serve the needs of startups to the enterprise. So one last demo, guys, right? You want to come up and tell us a little bit about how Azure SQL scales?
Sure.
Okay.
But I think now Mark, you want to show something, right?
Yes, my turn to do some demos.
Yeah. Go for it.
Okay, so Bob talked about two technologies, Hyperscale Serverless and Hyperscale Elastic Pools. So I'm going to show two demos describing that. So the first one is Hyperscale Serverless. With the arrival of Hyperscale Serverless Autoscale, you're now able to configure hyperscale compute to either provision or serverless. Serverless resources are autoscale and built on a per second basis, both from a vCore and memory perspective. In order to configure the Hyperscale database autoscale, you have to specify min vCore, which is in this case is 2, and max vCores, which in this case, I would choose the default. When the database is not in use, you're charged for the min vCores. If not, it's based on the autoscaling actually works from the resource usage perspective. We have triggered a workload here, so let's see how it works. Starting now. And if you can see in the last 5 minutes, there has been no CPU usage. As this workload ramps up, it demands resources, and resources are scaled on demand almost instantly. As we can see, CPU has jumped from 0 to now 40%. And if we wait a little bit longer, we'll see that it will go up to 6,000 batch requests per second. So it's not only about CPU, but it's also about memory. If you take a look at the memory is also ramping up almost instantly as well. Going from a 5-minute mark, let's see if it really works across multiple hours. So let's say you have a workload which goes up and then it goes down throughout the day. How does it really perform, and are you really built accordingly or not? So let's see if that actually works in this case as well. So I have a view to actually look across the last 24 hours, how your workload scaled and how your CPU memory both went up and down, and then they were built. And this is the view. You can see that going from this 5-minute to last several hours, the different points in which your application requires resources. Resources are ramped up and then ramped down. When the resources are not used, resources are not built. That means your database is not built. You're only built for the min vCore or based on your application workload. So when the database was doing nothing, you're built for the min vCore in this case. At the same time, as the application requires CPU, you can see CPU scales up instantly and also the memory. But we are a little bit conservative when we actually have to give up memory because we don't want to cause like a hot cache issue or some issue like that. So we are releasing memory a little bit slower than the CPU. You can follow the usage chart here and see that billing chart is indicating that billing is only used when your resources are up.
That's cool. So just to summarize, basically, even with Hyperscale now, I pay only for what I use, and you automatically scale up and down as needed based on my work.
Exactly.
So up to 100 terabytes. Amazing.
That is true.
Now, the question for you is, this is for one database. But if I am an ISV and I have a fleet of database or a bunch of database and I want to kind of spare a little bit of money and optimize my cost, what do we offer?
That is really the case from startup to enterprise, right? So let's say you are a customer, one of our customers, and you have several of your own customers, right? And each of those customers have their own ticketing system. So I'm taking that as an example of a startup. Let's see how that works. So I have a demo for that. Cool. And I have to speak really fast because this demo is really going into the future and showing you a few things. So let's say you are a ticket selling company that has many customers of your own. Each customer is selling tickets, for example, ski tickets, concerts, and many more. With Azure SQL Hyperscale Elastic Pools, the new technology that Bob just mentioned, you can create multiple databases which share a common set of resources like compute, memory, worker threads, and so on. On the Azure portal, to create a Hyperscale Elastic Pool, you give it a name, select the Hyperscale as the service tier, specify the number of vCores, in this case 16, for the Elastic Pool, and then hit create. In just over a minute, the Elastic Pool is ready to use. You can go and set the policy at the pool level to ensure equitable resources distribution between the databases and the pool. You can also use the Azure portal to create the first database in the Hyperscale Elastic Pool. Later, your application can create these databases per tenant on a programmatic basis if you want to. Fast forward to the future, your company already has, let's say, 8 very active tenants. Many tenants have announced special sales for the tickets for anything that's coming up. For the upcoming sales season, you can conveniently monitor the resource utilization of the Elastic pools and individual databases in the pool. With all these sales happening, you now notice that the pool is running close to capacity. CPU usage is around 90%. So you decide to take action and scale the pool up. You can do this by using Azure portal, going to the configuration of the pool, adjusting the resource allocation to 24 vCores, and simply hit save. After scaling the Elastic pool, you find that the CPU usage at the pool level of is a comfortable 60% or less. So you're happy with this configuration. Now, fast forward again, more tenants have launched tickets and application, and their activity and data grows. Your company loves the fact that Elastic Pool seamlessly auto-scales storage without any intervention needed. You can view the pool level size here directly, and it's grown to 16 terabytes. Wow. 18 terabytes. Wow. You can as easily monitor per database resource utilization using the portal as well. Let's say you notice a database for the ski tickets, which is a database called tenantdb05, is idle as the ski season is over. So this may be normal. You can use the Azure portal to move the tenantdb05 to another pool called Hyperscale Pool 2, which has lower amount of vCores. So with Hyperscale Elastic Pool, love the fact that you can quickly balance workloads by moving database across pools. This way, your company is completely set up for success for the future needs as you get your own customers.
Oh, that's pretty cool. And if I can imagine this with all the features that we showed before, I can really go from my startup, basically paying nothing even for free to start, and then ramp up to as many database I want and up to 100 terabyte automatically scaling up and down. That's pretty cool.
Yeah.
What do you think?
Awesome. Yeah, that's some good stuff. Yeah, really good job, guys. Hey, wait a minute. You can't leave yet. Okay. Come on over here for a second.
Yeah?
So, Wazma Devane, we're getting ready for this thing, and you sent me this email going, hey, Bob, check this out. What is this?
That's the architecture you can build today. It is a modern architecture. So you have, for example, event-driven architecture where you need to react to events that happen maybe on database or outside database. Let's say, for example, that when an order is made on database, you want to use SignalR to update a website in real time. Or you have mobile apps that need to query database using GraphQL and a distributed cache in just to make sure that everything is as fast as possible. You want to have telemetry, you want to have analytics. Now, all of this is possible today with database, Azure SQL Database at the core, because we have integration with function, we can push event, we can publish data, we can call REST endpoint, we can scale up, out. So it's everything that a modern architecture needs is here, and the root is Azure SQL Database.
All right, now I'm looking forward to the blog where you're going to tell everybody about how this all works together.
Yes.
Thank you so much.
Thank you
Thank you very much. Hey, I hope you enjoyed our session today. I hope you learned that we believe from startups to the enterprise, we give you local development experiences, app development experiences, and a platform you can rely on that is secure, performant, and available. Again, the deck that you see today is on aka.ms, bobwardms, and we'll be happy to stay here afterwards to answer your questions, or we'll see you at the Table Talk lunch. Thank you so much for your support of this event, and thank you for your time today.